Hello guys, can someone confirm if you're able to hear me on the chat please? And if you're able to see the screen, I don't think you'll be able to see the screen as of now. Just 1 second. Yeah, now. Okay, someone please give me a confirmation in the chat. Cool. So let us get started. So today's session is going to be slightly shorter session compared to others. We'll solve three problems. Okay. So what were we doing in the previous class? I think we were talking about array patterns and we have discussed the two pointer approach and we have discussed the sliding window approach. So today's idea is that we will take another pattern which is called as binary search and we will try to solve some problems from binary search. Okay, but before we do binary search, let us do one warm up problem, a simple problem which is called as a two sum problem. Okay, so let us, it's not a part of this sheet, so I'll probably add it here. Okay, and let me go to my Leetcode and let me search. I think it's the problem number one, two sum. Okay, here it is. Okay, so we are going to solve this problem. Let me add it here. Let me call it two sum. So this is a basic array question, or you can say this is, let me not give it away. Okay, so this will be question number one, and then this will be two, and accordingly, all the questions. So let us read the question and then try to solve it. Is everyone with me, guys? I think there is a little bit of lag, so I'll just continue anyways. So the question says that given an array of integers nums and an integer target, return indices of the two numbers such that they add up to the target. Okay, so by far from what we have read in the question, let us try to make sense of it. Okay, so the question says that I will be given an array of integers nums. Okay, fine, nums, and let that be 2, 7, 11, and 15. Okay, and it says that we will be given an integer target. Okay, so I will be given a target. Let's say the target is 9. Okay, and we need to return indices of the two numbers such that they add up to the target. So we need to find out which two numbers inside this nums are such that they add up to the target given. So in our question, the if we look at different pairs of numbers, we see that 2 and 7 is adding up to 9. So that's pretty simple because the first attempt itself we are getting the answer. Or if 2 and 7 would not have been answered, then we would have checked other possibilities like 211, 215, and then 711, and then 715. So you get the gist. From what we have done so far, you will be able to, you must be able to come up with something. Okay, so let us take this question down and try to understand the brute force approach for this. Okay, so we are talking about Leetcode 1 and this is called as two sum. Okay, so can someone quickly give me some ideas in the chat as to what could be the first possible approach for this question? So the nums is 2, 7, 11, and 15. So we have nums is 2, 7, 11, and 15, and we have a target. Target is 9. Okay, so and we need to return the answer should be 0 and 1. So we need to return the indices. We need to return the indices of those numbers which add up to 7. So here it is 0, 1, 2, and 3. So 0 and 1 are adding up to the target. So we need to return 0 and 1. Okay. So what can we do here? What will be the brute force approach? We need to find pairs of numbers. So we'll have to find out all possible pairs in this array, right? So if you want to find out all possible pairs, then we can maybe start from 2, 7, 11, and 15. And you can say that, sir, we will consider this 2 and try to pair it up with all the possible numbers. So 2 and 7, 2 and 11, and then 2 and 15. And the moment we get the target, we are going to stop the iteration and return the index. Okay. So 2, 7, 2, 11, 2, 15. Then we'll check 7, 11, and then 7, 15, and then 11 and 15. So these are the possible pairs, right? So can someone tell me quickly what would be the time complexity of this? Ashish Kumar is saying see every possible two sum. Yes. So that is the brute force. So this is the brute force. So what would be the time complexity of brute force and how are you going to write it? You'll possibly write a for loop for I in range of length of nums, and then from I plus 1 to range of length of uh, I plus 1 onwards till the end of the list, and you will try to find the sum. So you are going to run two loops. Mandeep is saying that O of n. So it's not going to be O of n, because intuitively you should be able to grasp here that for 2 you are checking all the elements, then for 7 you are checking all the elements, then for 11 you are checking all the elements. So for every element you are roughly checking all the other elements, which means if there are n elements you are going to check n times n elements. So that time complexity is going to be O of n squared. Is this part clear to everyone, guys? Why I am saying O of n squared, and how, why did I say that intuitively this should come to you? This is a very classic case of O of n squared. Without any thought, this should come to you. This is the brute force. All clear, guys? Still here? Okay. So this is the brute force. Definitely, we can write the code for this. So that brute force code I'm leaving up to you how to write. It's very simple. You iterate from I onwards and you check all the elements I plus 1 onwards. And whenever you get the element, you return I and j if I and j are your variables that you're using for the loop. So I want to talk about the optimized approach. Why I chose this question for a warm up today is because in the previous session we were talking about sliding window, and we did a question where we were trying to keep frequencies of strings, or I think we were doing some question related to sliding window where we were trying to keep track of values using a dictionary, if I'm not wrong. If I remember it correctly, I think we were minimum size subarray sum, longest substring with repeating characters. I think we were doing it, but if not, then fine, let us do it here. Okay. So if I frame the question a little bit differently now, okay, if I frame the question a little bit differently now and I take the same example, which is 2, 7, 11, and 15. Let me take another one. Let me take 3, 2, and 4. This is my nums. And I have a target which is equal to 6. Okay. So if I look at 3, okay, if I look at the first value, which is 3, okay, if 3 is supposed to be in the answer, or index of 3 is supposed to be in the answer, okay, Rahul is saying this question is covered in live class. No, we have not covered this question. First time I'm doing. Okay. If 3 is supposed to be in the answer, then we know the target. Okay. Target is equal to 6. Then what are we looking for? We are looking for a 3. Correct. So if one more 3 is present in this nums, then only this 3 can be the answer. Otherwise, these 3 cannot be the answer. Is that correct? Okay. So we move to what we can do. We can keep a dictionary here somewhere. Okay. That 3 is present at maybe index 0. Okay. And then we move our pointer. We move this pointer to 2. Okay, we move the pointer to 2, and if 2 has to be my answer, if 2 is supposed to be a part of my answer, then if the target is 6, then 4 should be present in my list, because if 4 is present, then only 2 and 4 can make a pair and I can get the answer 6. Okay, and I can see that 4 is not present in my reference. Let me call this reference. I'm creating a reference dictionary. Okay, so 4 is not present, so let me put this 2 also in the dictionary, so that if I encounter a 4 later, I will be able to find complementary of 4, which will be 2. So complementary of 2 is 4, complementary of 4 is going to be 2. So if in future we encounter 4, then I will ask you the question that if 2 is present in the dictionary, 2 is present in the nums, in that case we will be able to find the 2. So let me put here 2 is present at index 1, and I'll move ahead. Okay, and I will come to 4. The moment I come to 4, I'm going to ask the question, if 4 is supposed to be my answer and if the target is 6, then I'm looking for a 2. Is 2 present in my dictionary? Yes, 2 is present in my dictionary. And 2 is present in my dictionary at index 1. And 4 is present at index 2. So 2 and 4 can be my answer. Is this approach clear, guys? Why this works in O of n? Because if we are trying to find if you're trying to find a value in a dictionary, that is O of n. Finding a key in a dictionary is a O of 1 operation. Why it is O of 1 operation? That we will learn when we talk about hash maps. For now, just know that searching for something in a dictionary, or searching for something, checking for a membership in a dictionary or in a set, is a O of 1 operation. Guys, did you understand this approach? Based on this approach, there is one more question that I will tell you, which you can solve after the live class. Ashish, Rahul, Anil, Manpreet, Abhimanyu, Rajesh, Tyler. All clear, guys? Just give me a yes in the chat. Should we write the code for this? So what is going to be the code? We are going to iterate on every value. We are going to iterate on every value. And for every value, we are going to find the complementary. And we are going to check if the complementary is present in the reference dictionary. If the complementary is present in the dictionary, then we are going to return that value. If not, then we will go to the next value. Once again, okay, you did not understand. Okay, let us do one more example. Okay, this pattern is very important. So let us take some time. Let us take an example of 2, 7, 11, and 15. Suppose nums is 2, 7, 11, and 15. Okay, and let me say that the target that I'm looking for is 21. This is my target. Okay, so what I will do, I will start with 2. Okay, if 2 is supposed to be in the answer, if 2 is supposed to be in the answer, then what should be the pair of 2? Because I'm looking for a pair, 2 should come along with some value, right? So 2 should come along with 19, then only this can be the answer, which means 19 should be present somewhere here. Okay, so far 19 we have not seen, so we will keep a reference of values which we have seen. Okay, so till now we have not seen anything. If 19 is present in the future, in the subsequent values, then we will be able to get it, but as of now we have not seen it because we have just started. So we'll just say that we have seen the value 2 at index 0. We'll keep track of it and we will move ahead. we'll go to 7. If 7 is supposed to be my answer, okay, then the target, then the other value has to be 15. So we have not seen 15 yet. Okay, so we'll just say, we'll keep track, we will remember that we saw 7 at index 1, and we will move ahead. We'll come to 11. I'll say that if 11 is supposed to be my answer, okay, if 11 is supposed to be my answer, my target is 21. If 11 is supposed to be my answer, then I need to have 10 as a value. 10 should be present here. 10 I have not seen. I have only seen 2 and 7. So fine, I will add 11 here. And I will say I saw 11 at index 2. Okay, I'm doing a dry run. Then I will come to 15. Then I will come to 15. And I will say if 15 is supposed to be my answer, okay, then I need a 7 so that this can become 21. And when I come to 15, I will see that I have seen a 7 already at index 1. Okay, so if this is 0, 1, 2, and 3, so 15 is at index 3 and 7 is at index 1. So this is my answer. Okay, so here what is the time complexity? It is O of n. So we first wrote the code brute force as O of n squared, and then we have optimized our code from O of n squared to O of n. Is it clear now, Rahul? Should it be 14 and 7? 14 and 7 will be 21. Sorry. Make it 22, whatever. Okay. Yeah, yeah. Fine, fine. Got it, got it. 15 plus 7, 22. Sorry. Okay. This should be 11 here and this should be 20 here. I hope, but you got the idea. Okay. Can we write the code, guys? Let us write the code. Manpreet is asking this approach comes under which category? It is a mix of array and hash map. Array and hash map. Okay, there's no such pattern. It is just frequency counting using, you can say, it's a type of frequency counting using hash map pattern. Okay, it's not binary search. I'm just doing it separately, one question. Okay, because it's a very basic question. Okay, so what we will do? We will iterate for I, and we can use for I in range nums. Okay, what we'll check? The complement. So what is complement? Complement is target minus nums of I, or you can use a one enumerate here. Okay, and you can say complementary is target minus num. And I will say if the complement is in, if the complement in my reference. Okay, so I will keep one reference here. Reference is going to be my empty dictionary. If complement in reference, then what I'll do? I'll just return what? Reference of complement and I. Okay, or you can say I and reference of complement. If that is not the case, then what we will do? We will just add that to our dictionary. So we will just say that reference of num is equal to I. Are you following, guys? Can we run this and see if it works? There's a mistake here. It should not be this. Enumerate. Tuple unpacking error we got. Typo error, of course. Mm, Again, typo error. Seems to be working. Okay, it works. Okay. Now let us try to understand binary search, the concept of binary search which we are doing. So binary search problem. Let me go and look for here. We'll do one basic of binary search and then we will do one question on binary search. This is question number 704. Okay. I think I've explained this earlier, but let us discuss it one more time. It's a very important topic. And then we'll do maybe two questions. One and one we'll solve this. This is a template question for binary search. And then after that, we'll do one more question. Then we'll call it a day today. Okay. So binary search is a type of searching algorithm. Okay. And all of you must have heard of binary search. I mean, all of you must know, must have played with this binary search knowingly or unknowingly. You may not know the term binary search, but definitely you must have come across this idea. I'll just show. I'll just when I explain it, maybe you will be able to recall. But let me first just explain what is linear search, so that you get an some context of what I'm talking about. So linear search basically means that if we have an array, maybe 4, 3, 2, 8, 6, and 10. Okay, this is nums, and I'm asking you to search for a value called 2 and return the index of 2, right? So this is 0, 1, 2, 3, 4, and 5. Okay. So the way we search in an array is that we start with the starting element of 4 and we check whether 4 is equal to 2. 4 is not equal to 2, so we go to 3. 3 is not equal to 2, so we'll go to 2. Here there is a match, so here we are going to return true. Okay. If 2 doesn't come here, then we'll keep searching till we reach the end of the list. Okay. So by this virtue, this operation, the name itself says linear search. The time complexity is O of n. Now the idea is that if our array is given to us in a certain way, if the array that is if the array is given to us in a sorted way, then can we do something better than O of n? So when we learn about arrays, we talk about sorted arrays and unsorted arrays. Okay, mostly when we discuss about low level arrays, we talk about unsorted arrays, but there is a category called sorted arrays. Okay, in which we can use binary search. So you must have played this game very often, that I have a number in my mind between 0 to 100, and can you guess which number I have in my mind? Okay, so the question is that how many attempts it is going to take you, how many attempts it is going to take you to guess the number that I have in my mind. Okay, so if I tell you I have a number in my mind, Abhimanyu is asking if there's a duplicate number. Normally when you do search, you return the first occurrence of that number. Okay, so I was saying that I have a number in my mind which is between 0 to 100. Okay, how many attempts will it take you to guess that number? Okay, so let us say that the number that I am having in my mind is 53, suppose, or let me not take 53. Let me take that the number that I have in my mind is 13. Okay. So if someone does not apply much of logic, what he will do? He will start asking you 0. Do you have 0 in your mind? I'll say no. I'll say 1. 1 do you have? 2, 3, 4. Like that, he'll keep guessing. Okay. And by the time he reaches 99 or 100, that is when he will get his answer. So worst case, it is going to take 100 attempts. This is called as linear search. Okay, which is O of n. If I told you that I have a number in my mind between 0 to 1000, then it is going to take you 1000 attempts. And if I say the number is between 1 and 1 million, then it is going to take you 1 million attempts. Okay, but if we try to translate this problem to an array question, then it basically means that I have an array of numbers from 0, 1, 2, 3 up till 98, 99 and 100. Okay, let me draw it in a better way. Let me write it like this. Okay, I will have maybe 25, and then I'll have 50, and then I will have 75, and then like this I have this big array of numbers, and I'm asking you to search for one number inside this. So how many attempts it is going to take? So what binary search says is that, or if this you are playing this game, the person might say 50. The first guess would be 50. Okay, 50. Okay, and you can say whether the number whether the number that I have in my mind is bigger than or lesser than 50. Suppose if you say that the number that I have in my mind is 13. So I say that the number is less than 50. So if the number is less than 50, then do I need to check this space? I don't have to check that space. Right? I don't have to check that space. So what has happened? My space has become 0 to 49. And again, I have the same problem. I have an array and I want to search for a number. So earlier I took the middle value. Again, I'll take the middle value and I'll say 25. And I will ask you whether the number is lesser than or more than 25. Suppose if the person says it is lesser than 25, then what has happened? Your search has come to 0 to 12. Sorry, middle of this will be 25. So it has come from 0 to 25. And again, we have the same problem. We have an array and we want to search for a number in it. So again, we'll take the middle value 12. So do you get the gist that every time I'm taking an attempt, I am reducing my search space to half. So if I started with 100, from 100 I go to 50, from 50 I go to 25, from 25 I go to 12, from 12 I go to 6, from 6 I go to 3, from 3 I go to 2 or 1. So 1, 2, 3, 4, 5, 6, 7 attempts. Okay, guys, are you getting it? If I was having 1000 numbers, so from 1000 I would have come to 500, from 500 to 250, 250 to 125, 125 to 64, 32, 16, 8, 4, 2. This many attempts. Can you see that if we did a linear search, we would have had to take 100 attempts, and 1000 means 1000 attempts, but here you see I took only 7 attempts, 6 or 7, and here I took 1, 2, 3, 4, 5, 6, 7, 8, 9, 8 or 9 attempts. So we multiplied, our input grew by 10 times. Our input became 10x, but the number of attempts became increased only by 1. So what behavior is this? We say this is a logarithmic behavior. We say this is logarithmic time complexity. Do you guys understand logarithmic time? Or we say O of log n. Why O of log n? Because we want to ask, okay, number of attempts. Okay, so how many times can we multiply 2 by something in order to get to 1000? Okay, or you can say that 2 to the power of x is equal to 100 or 1000. So x is what? X is log of 100, or you can say log of n. N is the number of input size. So whenever you are dealing with arrays and you come across sorted arrays, and you are working with an algorithm and you're getting maybe O of n, and you are being asked to optimize it, somewhere or the other you have to use binary search most of the time. If you are coming across sorted arrays, then try to think of binary search. And log n is very, very efficient compared to the linear search. I think I have shown you the proof. Okay, this is linear. This is what we call linear, and this is log. Okay, so now if we try to think of in terms of how are we going to write the code, so this is also an example of two pointer approach. So this question is also an example of two pointer approach where we can go and write 1 2 like this, maybe till, let me take till 10. Okay, so every time we need to find the mid value of whatever array we have, and based on that we need to shrink our search space either to the first half or to the second half, right guys? So I'll take two pointers here, I'll take one pointer here, and I'll take one pointer here, and I will call this the left, and I will call this the right. Okay, and whatever is between left and right is my search space. This is what I have to search. Okay, so I'll take the middle value of this, I'll take the middle value of this 5, and I will ask if my middle value is greater than the target. It is possible that my mid value is less than the target, or it is possible that my mid value is equal to target. If it is equal to target, then the problem is solved. We will return. But if the middle value is less than the target, if the middle value is less than the target, then what we should do? Middle value is only less than the target, then what we should do? There is no point in searching to the left of mid. If the middle value is only less than the target, then everything left of mid will be less than the target because it is sorted. So we will take the left pointer, and we'll take the left pointer and we will move it after mid, and this becomes our new search space. This becomes our new search space. Okay, so what we will do, if mid is less than the target, then we will say left is equal to mid plus 1. We will only focus on the right hand side, Kamal. Okay, and if the mid is greater than the target, if mid itself is greater than the target, then everything on the right hand side is going to be greater than the target. Then we need to focus on the left side. So this will become our span. So if this is left, then this will become our right. So we will say right is equal to mid minus 1. And we will keep doing this. We will keep doing this. We will keep doing this while, guys, this is the template of binary search. This is very, very important. Keep in mind, this the question that we are going to solve is the basic question of binary search, but this idea is going to be implemented in a lot of questions. We'll say while left is less than right. We are going to continue doing this, continue shrinking until we find the until we hit this conditions. At some point we are going to hit this condition. If we don't hit this condition and left and right have come together, that means the value does not exist. In that case, we will return minus 1. Did everyone understand binary search? Can we write the code for it? Chalo. Saif Akhtar is saying this question was already done in class. Okay, fine. I didn't. Binary search, I think, yes, we have done in class. Not, we have not done binary search, but I think I was showing you when we were talking about time complexity. Then I think I discussed about binary search for to show you what is logarithmic time complexity. But binary search we'll discuss in class also. Um, I just thought I'll give an explanation here. It's here also because there are other people also who are joining. Okay, chalo, let us write the code for this. So what are we going to do first here? The first thing here that we have to do is that we will take the array. Okay, so the array is -1, 0, 3, 5, 9, and 12. So first we'll take the left pointer and we'll take the right pointer. So left pointer is going to be 0 and the right pointer is going to be this one, which is length of nums. Correct? Okay, and then we'll find the mid value. Okay, we'll find the mid value. How are we going to find the mid value? So left and right. Okay, if left is 0, right is, this is 1, 2, 3, 4, and 5. So 0 plus 5, and we will do this division by 2. Okay, that is how we'll get it. Guys, I will suggest, please definitely do a dry run of this using pen and pencil, using pencil and paper, with your hands. Okay, that is how you will internalize this binary search pattern. On a higher level, it is very simple. On a higher level, it is very, very simple. But when you try to code it, very often you will get stuck with a few things. Okay, so it is very important, and binary search is going to be a small part of a bigger problem. So if you're solving a difficult problem on graphs and all, then very often you have to use binary search sometimes in many other questions. So there will be a lot of code, and binary search is going to be a part of it. So you should not spend a lot of time on writing binary search. It should be very, it should come very fluently to you, the logic. Okay, I'll just say left is equal to 0, and my right is going to be length of nums. Okay, length of nums minus 1. And then what we will do, we'll say while left is less than or equal to right. Okay, we'll calculate the midpoint. So midpoint is going to be left plus right, floor division by 2. Okay, we are finding the midpoint. And I told you that once you have found the midpoint, the mid can be, if the mid is equal to mid is equal to the target, which means if nums of mid equal to target. Okay, if, then we simply return mid. Okay, because we want to return the index of the value, right? If the target is bigger, if the target is larger than mid, okay, which means if nums of mid is larger than the target, then we are going to ignore everything on the right hand side. Okay, we are going to ignore everything on the right hand side. Let me align it properly. Okay, and I will say right is equal to mid minus 1. We'll focus on the left hand side, so we'll move the left right pointer to the left. Else, sorry, this should be elif, and I will say else, the third condition is going to be left is equal to left is equal to mid plus 1. If after doing all this, if we don't find anything, then just we can return -1. Okay, if the value is there, then this condition will be satisfied. Some time or the other, this condition is going to be satisfied. Okay, so focus on the left side, left half, and this one is focus on the right half. Can we run this code, guys? This is running fine, and then let me submit this. and this is working. Are you following, guys? Did you understand? Can we do one more question on binary search, application of binary search? Okay, let us do question number 33 on Leetcode. Okay, what does the question say? Let us try to see the question. Guys, take a moment to read the question, please. The question talks about a sorted array. Sorry, not this question. Let us do a simpler one. What is it called? Minimum. Yes. We'll do minimum in a sorted array. Minimum in a sorted array. Once you have done this, then you can do that one. Okay, this is simpler. Let us do 153. I hope 153 is a part of our question. Yes. Let us do 153. Please take a moment to read the question. What does it say? The question says that we have to find the minimum in a rotated sorted array. So before we read the question, let us understand what is a rotated sorted array. Okay. So if we have a sorted array which is 0, 1, 2, 4, 5, 6, and 7. Okay. The question says that suppose I want to rotate it by 4 steps. Okay. So if I want to rotate it, what will happen? 4 steps. You see, this 0 will come 1, 2, 3, and 4. So 0 will come here. Okay. 1 will come here, and 2 will come here, and 7 will go behind. Okay. So 7 will come here, and then 6 will come here, 5 will come here, and 4 will come here. So this is a rotated sorted array. Do you guys understand this? What is the meaning of a rotated sorted array? There are a lot of questions based on rotation of a sorted array. Let me take this separately and try to 153 find minimum in a rotated sorted array. Okay, and there is a certain property of this rotated sorted array that we are going to use. Okay, so suppose we are having this rotated sorted array which is 0, 1, 2, and then we are having 3, 4, 5, and 6. It's like you have rolled them, and every element has gone from here to here. Guys, are you able to visualize what is rotated sorted array? Now, one thing is there in this rotated sorted array, that there will be two halves. Mohammad Saif Akhtar is asking, can you explain once again rotated subarray? Take a sorted array 0, 1, 2, 3 like this, and then rotate it. Rotate means, how do I ask you to visualize it? Put 2 here, 1 here, 0 here, and 3 here. So what will it become? I have rotated it one time. It will become 3, 0, 1, and 2. I will rotate it one more time. Then what will happen? 1 will come here, 0 will come here, 3 will come here, and 2 will come here. So it will become 2, 3, 0, and 1. So this is rotated one times. This is rotated two times. Now in, so we will I will be given a rotated array, rotated sorted array. It's not rotated sub array, rotated sorted array, and I need to find what is the minimum value in that. Which is the minimum value? Is the question clear, guys, to everyone? So if I just take an example of this one, if I take an example of this, and you'll see how binary search is going to come into picture here. Okay, I'll take this one and I'll take a left pointer here, and I'll take a right pointer here. Okay, and I will take a mid value. This is my mid. Okay, if the mid value, if the mid value, if the mid value is less than my right value, or if my mid value is greater than my right value, then what can you conclude from here? Based on your information of binary search and based on the fact that these are rotated, and once it is rotated, you know that there is one portion of this which is sorted in ascending order, no matter how I rotate it. Okay, there is always going to be one portion which will be sorted in ascending order. Using this information and using the knowledge of binary search, what can you conclude from this? If the mid value, for example this 3, if the mid value is greater than my right value, if the mid value is greater than my right value, can I conclude, can I conclude that my answer is always going to be on this half? Because if my mid value is greater than my right value, that means this part is sorted in descending way. This I want you to take a moment and try to visualize it in your mind. Guys, tell me in the chat. Will this always be true? Let us take another example. I'll take 0, 1, 2, 3, and then 4, 5, 6, 7, 8. I'll take one left, I'll take one right, and I'll take this will be my middle value 1, 2, 3, 4, 1, 2, 3, 4. This is my middle value. If my middle value, of course, when I say middle value, I mean nums of middle value, is greater than my nums of right, then definitely my answer is going to be in this half. If it is less, if it is less, for example, I'll take another example. Okay, I'll take 0, 1, 2, 3, 4, 5, 6, and then I'll put 7, 8 like this. Okay, I'm taking, this is my left, this is my right. Okay, so this is my mid. Okay, and if my mid is less than my right, which means what? If this is the case, then this means what? That my right side is sorted. Okay, so minimum has to be on left. Is this part clear? Guys, please tell me in the chat. So again, we will have the same condition which we have written in the binary search. We are going to write the same code. Again, we are going to have same condition, but the meaning of those conditions are going to be different. If mid is greater than right, and if mid is less than right. Okay. In this case, we are going to shift the left and right pointer according to what I have shown you. Okay. So can we write the code quickly now? I hope you guys understood. I'll say my left is equal to 0, and I will say my right is equal to length of nums minus 1. Okay. And I will say while left is less than equal to right. So this is the template. This is the same template that we used in our binary search also. Okay. And I will calculate the mid value. So mid value is going to be left plus right, and I'll do a floor division by 2. And then what I'm going to say, I'll say if my mid of, sorry, if my nums of mid is greater than right, let me check the chat quickly. Okay, glad to see that all of you are active. Chalo. If my nums of mid is greater than nums of right, then my low is equal to my left is equal to mid plus 1. Okay, this is what condition. If my middle value is greater than the right value, okay, then my right side is sorted. So I'm going to look for in the right side. So I will move the left towards the right side. I'll remove the left part of my uh, search space. Okay, else, okay, this means that if my, this is basically saying that my nums of mid is less than or equal to my nums of high. This indicates what? The right side is sorted in ascending. Okay, so if right side is sorted in ascending, then my minimum value, every value on the right side is going to be greater than mid. So my minimum possible value can be mid or lesser than mid. Okay, so this will be, I'll say right is equal to mid. Okay, I'm not doing mid minus 1 because mid also can be my answer. So I'm just saying right is equal to mid. Now you see, when you are doing binary search, these are the things that you have to take care of. Okay, here I'm not doing left than equal to, I'm just doing less than. So this idea you will get when you're doing a dry run. Take an example and try to run it through the code. That's when you will understand that when I'm using less than and when I'm using less than equal to. Okay, and when I'm using minus 1 and when I'm not using that. Okay, so question to question this is going to differ. So I'm going to return here, return nums of left. Okay, I hope this works, please. Thank god. Okay, take this question and try to do a dry run on this. Take one example and try to move the pointers and see what I'm saying, if it makes sense. Take examples on your own. The idea that we are using here, the core idea that we are using here is that one half will have sorted numbers. When I say sorted, I mean ascending order. We'll have sorted numbers always. Because even if you rotate it, even if you rotate any set, okay, you see here, even if you rotate this set, this part is sorted, this part in ascending order. Okay, so if you are standing here, okay, and if this value is less than this value, that means this entire thing is sorted. Okay, that means my minimum possible value can be this or something on this side. Minimum possible value cannot be on this side. So that's why we are doing left is equal to left, sorry, mid plus 1. If that is not the case, if that is not the case, then my answer is on the other side, and mid can be a value. So then we are doing right is equal to mid. We'll move the left right pointer to the mid here. Okay, that's all, guys. I think we have done 3 questions today, and let me mark this question as done. This is 153, so let me mark this as done. See, in the sheet there are a lot of questions on binary search which I have put here. Okay, 704 is the classic question, and 153 is the question you should do if you have just done binary search. Okay, and then we have search insert position. So question number 35 you should be doing, and then question number 33 you should be doing. Okay, these 3 questions you should be doing, these 2 questions on binary search. So if you do 4 questions on binary search, you will get a good introduction to binary search. Okay, but then I have written here, I have put here 1 2 3 10 questions on binary search. So if you do 10 questions on binary search, you can say you have some idea of binary search. Okay, at least you will get an habit of writing this pattern. This pattern. Okay, so next class I think we'll continue with binary search, and we'll also do prefix sum. Binary search and prefix sum, we'll try to mix 2 questions. We'll do binary sum and then binary search, and then we'll start with the prefix sum pattern. After that we'll start with linked list. We'll do some questions on linked list. So you can see here I have added questions on slow and fast pointers. These are all linked list questions. Okay, so we'll do a lot of questions, and then we'll do some tree questions on BFS DFS. So if you do these, then you will get a good idea of um, the basics of data structures. Okay, guys, can we stop for today? It's already 10:01. We are on time. Anyone has any question, please put them down in the chat. Okay, guys, again, little bit of self promotion. You can check out the channel. Okay, this is my channel. Please go to the playlist section and you can check out the Python for beginners, hands-on Python for beginners playlist. This contains almost everything that you need to know about Python, right from the very basics, all the data types, control flow, till uh, exception handling and oops. And I've done a mini project on oops also. So if you do this much, you'll have a good understanding and good practice. There are a lot of practice sessions also where we just take questions and we solve problems. Okay, personally I believe that's the best way to learn, where you learn the theory and then you take some questions and you solve it. That's how things will internalize. And then if you've done that, then go through this DSA playlist. This is in Hindi, so those of you who are comfortable in Hindi, there are 3 topics which I've covered in very detail. I've added the Leetcode questions and I've added gate questions, MCQ questions, and everything I've implemented from scratch. So try to watch this video. Okay, if you like it, then please share it with others. And very soon I'm going to upload a very detailed video, 3 or 4 hours video on arrays also. Okay, so in a few days that will also be up. After that we'll do trees and graphs and other things. So that's it for today. Okay, guys, and I'll see you next live class, which will be Thursday. Bye. Take care. Good night, guys.